I see that it is 8:30, so we're going to get started this morning, unpacking the nuances of material health. And I'm joined here today with Lauren Heine, who is the Director of Safer Materials and Data Integrity at ChemForward, and Jay Bolus, who is the President of MBDC. And I have to say that we have the two icons in the industry here for this sort of conversation. So anything you ever wanted to know about material health, these are the two folks to be checked. So a bit of a technical subject. We're going to start with a couple of slides and we will save plenty of time for conversation and discussion. But Jay, if you could start us off, please.
Yeah, absolutely. Thanks, Nina. Appreciate the introduction and kind words. Yeah, so as Nina mentioned, I'm Jay. I'm president of a company called MBDC, founded by Bill McDonough and Michael Brongart. And we are the creators of the cradle-to-cradle design protocol, paradigm, and also the cradle-to-cradle certified products program. You can click, Lauren, thanks. Okay, so just a quick refresher on cradle-to-cradle design, right? If you take anything away from my piece today, it's this. Cradle-to-cradle design at its foundation is about safe and circular. Safe first, circular second. Okay, we can click. So, you know,
expand slides. Is that a possibility? If not, don't worry about it.
It's in the slide.
Sorry to interrupt you. Go ahead.
I don't know if that did it on my screen. I don't know if that did it.
It says you can double click it
for everybody.
If on your own screen. So not you, Lauren, but people can double click the slide. Okay. So go ahead, Jay. Sorry.
Cool. Okay. Yeah. No. Thanks. Right. So what does it mean to be safe? And Lauren's going to talk about this in a bit more detail. But essentially, what it doesn't mean is that you just compare your substances against an RSL or against a ban list. That might be important to eliminate the most egregious substances, but to really understand your product or material from a true safety perspective, you need to understand everything that's there, and you need to evaluate it against a robust set of human and environmental health criteria. And that's fundamental to cradle-to-cradle design. So that's the safe part. And how about the circular part? Well, again, from the cradle-to-cradle design perspective, we look at circularity really in two ways. There are two cycles or metabolisms for which products should exist in the world. The first being the biological, and those are for things that can safely go back to nature, return to soil. And the second cycle is the technical cycle. And this is for those products that are durable, that can't go back to nature safely, and instead should go back to industry to be reused over and over again. So biological cycle for those things that are safely returning to nature, technical for the more durables that need to go back to industry. And the key thing to remember here is that while we show these as two separate cycles or metabolisms, they're actually interrelated in that the technical sits inside of the biological, which is a really important concept to remember, because that means if you're creating technical nutrients or things for the technical cycle, you have to be sure that they can remain in the technical cycle and not bleed over into the biological. And if they do, we have to make sure they're safe for that biological cycle. So before I turn it back over to Lauren, I just want to end with a little story about our friend here, the PET water bottle, and look at this from the safe and circular perspective, right? This is obviously getting a lot of press, as is all single-use packaging, and some people think it shouldn't exist at all. But just remember, 1 out of every 3 people on the planet doesn't have access to clean drinking water. So, you know, clearly there's a need for something like this. The question is this the right way to do it? So from a safety perspective, you may or may not know that PET is polymerized with a catalyst called antimony trioxide, which is a suspected carcinogen. Antimony levels in this PET might be 250, 300 parts per million at the end. And you know, from our perspective, that's a significant amount. So not sure we can check the safety box there. And if we go to circular, actually, this is the one plastic, I think, in the US that actually has a decent story with respect to recovery and recycling. But the question is, what is it being recycled into, right? Vast majority of these bottles are going into fiber, going into carpet, or going into fleece. And what happens next? I'm sure everybody is aware, unless you've been, living in a cave for the past couple of years, that plastics in the ocean, particularly microfibers, are a huge deal. And the vast majority of those microfibers are coming from recycled PET soda bottles. So here we have technical nutrient, not necessarily designed as safe, but bleeding over into the biological cycle and definitely causing some issues. So I think it's time we say goodbye to this and potentially look to redesign the water bottle. All right, on that note, I will turn it over to Lauren.
Okay, thank you. Let me just figure a few things out here. Alrighty. My name's Lauren Heine, and I'm Director of Science and Data Integrity at ChemForward. And about 20 years ago, I was just out of graduate school in environmental engineering, and I was a fellow in the green chemistry program at the US EPA. And on my first day, with the ink on my diploma still degassing, the head of the Design for the Environment program said to me, "So, how does it feel to know your degree is obsolete?" I was rather surprised, but he said, "Environmental engineering is about cleaning up waste at the end of the pipe. The future is about designing out waste and toxics from the beginning." And so I was hooked, and have been developing tools and frameworks ever since to help people make better decisions. So I led development of tools, including clean ingredients, green screen for safer chemicals, and others. And my current efforts are focused on ChemForward, which is a non-profit value chain collaboration committed to scaling access to chemical hazard assessments to help people make informed decisions about the chemicals and the materials they use in products. And this information is absolutely critical to designing products that are safe and circular. So what's exciting about being at this conference is that it is full of participants who understand the importance of systems thinking and product design wherever you are in the value chain. And in my experience, I don't know if this is true for you too, Jay, but people's eyes tend to glaze over within a few seconds of just saying the word chemistry, never mind dropping a few chemical names. You can try it sometime, but it's chemistry that defines materials and toxicity and what happens to matter in the environment. So having useful information, such as the endpoints that Jay just displayed, is essential, whether it's about the hazard, whether it's about persistence, whether it's about physical chemical properties like volatility. That information can help guide decisions about how to design products for a circular economy. Think about it. It's the inherent biodegradability of a chemical that dictates whether or not it can be composted or if it will degrade in a wastewater treatment plant. That's an inherent chemical property tied to its fate. So the goal of ChemForward is to gather the best available chemical hazard information, interpret it, and communicate it in a way that guides product design and safer chemical procurement. So how do you know if something is safer? What kind of information do you need to make safe and circular products? Jay touched on some of the attributes that are a part of defining biological and technical nutrients. But first of all, you need disclosure. What are the substances in the material? What are your options? You can start with safety data sheets, but it's much better to have full disclosure. You can then screen for priority chemicals of concerns. Jay mentioned restricted substances lists and things like that. That's a good place to start. Tools like Pharos are great and easy tools to use to screen a chemical against known or suspected hazards. that are based on hazard lists. For the next step, though, substitution, if you want to substitute a chemical of concern with a safer alternative, you really need to know what those hazards are. What is the profile of the chemical? And ChemForward collects all the available data and presents it in two different views. One is the view is associated with a globally harmonized system, classification and labeling, and which is GHS. The other is associated with the cradle-to-cradle view. So it's nice because there's a good contrast sometimes between cradle-to-cradle is more precautionary than GHS. So you can learn more in some ways using that view. But once better options are identified, you really need to dive into the details. And that way you can be proactive. In the very beginning of product design, select those chemicals that are inherently safe and designed for circularity. What chemical properties do you want in your product? What chemical properties don't you want? And as Maya Angelou said, do the best you can until you know better. And then when you know better, do better. So the next quote, I'm going to actually borrow from Jay, something you said the other day that hopefully will live. You mentioned sometimes you don't really know if something is safe until you try to make it circular. I thought that was a really good way to put it. And here is there's a very sophisticated paper mill, Inland Empire, in Spokane, where I live. And when it uses just wood pulp as a feedstock, they make paper with no emissions problems. It's very benign emissions. But when they take recycled paper, and including printed paper and paperboard, the mill becomes a polluter. And the inks on the printed paper, some of these inks contain inadvertent polychlorinated biphenyls, which are called PCBs. They're very persistent. And what happens is the mill now discharges PCBs into the river at levels, albeit very, very low, but at levels that are higher than what are allowed by this in the state of Washington. So what a trade-off, recycle paper or pollute the river. That's not a trade-off they should have to make. PCBs are allowed at very low levels in pigments, but those levels are too high for a circular economy. So in sum, the chemical hazard information and impurities in products is really critical information to have to make a safe and circular product. And sometimes you don't really know what safe means until you try to make it circular. But for both safe and circular, you're going to need chemical property and hazard information to make better decisions. So there you go, contact information, and I look forward to the discussion.
Great. Thank you both, Lauren and Jay. And I imagine you're going to get some questions, Jay, after this. Your thoughts on water bottles, but we'll leave that there for the moment. This issue of safe and circular becomes really important. And Lauren, in your example, I mean, that's a crazy example when you think about it, that here we're trying to use more and more recycled content. And my understanding is these materials are not regulated on the front end. So the inks and some of the other materials that cause these problems are perfectly legal to use at the beginning. And right. Some contribute to these more than others. Where there's a problem is at the end of the pipe. And so how do we close that circle? How do we connect? Maybe you could both answer this when you've got a situation, because we're in the same situation with PFAS, where we've substituted materials that we thought were better, and maybe they're not, and they're not regulated, but we're finding them at the tail end. So how do we conversation to close that loop when something might be legal to use, but it's going to cause problems for circularity? And maybe Jay, you could kind of go first on that one.
Yeah, I mean, I think, from my perspective, it goes back to design, right? And what are we doing at the front end? What problems are we trying to solve? Some of these coatings, PFAS and others, worked great at what they were intended to do, but we had pretty narrow blinders on, right? When we were thinking about the substance. We weren't thinking about end of use. We weren't thinking about next use. We weren't thinking about compatibility with biological or technical cycles. So for starters, I think we have to be smarter upfront on the design side of things and look at things more holistically and always think about next use. I don't want to say end of life because these things aren't alive. So it's, in our lingo, it's next use, right? What is the next use and how do these substances impact next use? Otherwise, we're forced trying to put a square peg in a round hole. Nobody ever thought, well, gee, how do you recycle a tire? That wasn't thought about when people made tires. Now we're stuck doing crazy things with them, right? As a result. So to me, it gets back to that design assignment and thinking about it up front.
Thank you, Jay. Lauren?
Yep, I can't disagree with that. And yeah, and I think that the issue of it's not just the chemicals themselves, it's also impurities. And so when you said that PCBs are legal in pigments, you're absolutely right. There is a limit. It's 25, it's supposed to be an average of 25 parts per million, max of 50 parts per million. But when you concentrate that and you and they don't break down, so it's very, even though this is a very sophisticated mill, they can't get them out completely. They go into the river. So the laws do need to acknowledge that it's not just safety in the use phase, it's safety across the life cycle. And so one solution would be for, the new TSCA to lower that limit a whole lot. But if government can't regulate it, then it's up to designers and to choose pigments that don't have PCBs in them, frankly, to stay away from diarylid yellows. They're a very popular yellow, but they typically have PCBs. So it would be moving them. You need more information and you need access to good functioning pigments that that don't contain PCBs, that will allow you to design for the whole life cycle.
So it sounds like you're both saying that.
Just one other thing to add, if I could. Sorry. And this just reinforces the point about RSLs aren't the whole thing, right? Because these inks and these pigments are RSL compliant in a lot of cases, but until you dig a little bit deeper and understand what's actually there and do the active assessment, you won't get to this point.
That's exactly where I was going. So thank you for that, Jay. Which is, okay, what does a company do? Obviously, they now have to ask this new question: is this material going to be safe when I try to make it circular? So that's takeaway number one for everyone to think about. But number two is, what do I do as a company? How do I learn what I don't know? And why aren't restricted substance lists enough? How do I get ahead of regulation so that I don't get in trouble because I didn't know that this was going to cause a problem? So who wants to take that one first?
Well, I'll just say one thing that's a problem is that the people who are using pigments with PCBs or making pigments with PCBs are not the people who are paying the price for not being able to recycle. That's the problem. They're passing the problem on to paper mills and recyclers, which, so there's a problem with, I don't think the word is really accountability, but responsibility, I guess. So it's really, the question is, what's the best way to intervene in the supply chain? Is it regulation? Is it voluntary initiatives? Is it better information so people can make more informed choices? And I think it's all of the above. Jay?
Yeah, no, I agree 100% with that. I mean, to me, the biggest issue here is the supply chain transparency, right? Because we don't have vertically integrated manufacturing really anymore. There's a few examples of it, but far and wide, manufacturers are buying components from somebody who's buying stuff from somebody else, who's buying chemicals from somebody else. So the traceability down the supply chain is really challenging. And that's the first place that I think companies and manufacturers need to start, right? put a system in place that increases your transparency down your supply chain. And it's going to be hard because a lot of the nodes of that chain are going to say this is proprietary, right? It's confidential. This is my confidential business information. So I'm meeting legal requirements, go away. I'm not going to tell you what's in it. But, you know, the manufacturers have to be persistent, have to be stubborn, and insist on supply chain being more transparent with them about the stuff that's in the things they buy.
That's right. And I think there's a lot of education, and what's exciting of being at this conference is so many people understand the importance of systems thinking and life cycle thinking, but we need to change the way we think about products and materials to think in terms of metabolisms, life cycle, supply chains, and that's going to be a cultural shift that affects design, industry, and regulations.
So you've both said restricted substance lists aren't enough and you need to ask better questions. You've also said that oftentimes you're going to hit a wall where the company is going to say, I am meeting legal requirements, go away, to use your words, Jay. So what does a company do? And we only have about 4 minutes left, so 2 minutes each. How do they get this information? How do they become better? Jay, why don't you start?
So just a couple of examples of companies that I personally work with is that, look, they've got the purchasing power. Their suppliers will listen to them because they speak with their dollars. And I've had instances where companies will say flat out, we will not purchase material from you unless you share formulation information either directly with them as a manufacturer or with a trusted third party, you know, like ourselves, who can at least evaluate the safety of that material and let us know whether we should use it or not. So, you know, manufacturers have a lot more, they have a much bigger stick, I think, than they realize.
Great.
Yep, that's good. And Cradle to Cradle looks at very, very low levels in ingredients, so you can get at some of these impurity issues. But I think from the perspective of ChemForward, what I would say is we're building a repository of green building blocks. And I think it's a lot easier to start with safe and green and safer materials that are about first than it is to take a product, kind of dismantle it and rebuild it. So if you know what you're dealing with from the beginning, you know the hazards, you know the purity, it's a lot easier to make something that you're not going to regret down the road and have to remake. So starting with green building blocks in the first place at the chemical level, I think is a really good strategy too.
And would you both say, I mean, one of the things I've observed in packaging is oftentimes when someone is designing a package, they don't think about the inks, the coatings, the adhesives, or even some of the additive packages that are required to make a resin or a material perform the way it's supposed to be. Those are kind of out of sight, out of mind. But it seems to me, from what you're both talking about, those are the places where many times these problems occur. Right? Wrong?
Absolutely. No, you're absolutely right. It's traditionally right. It's cost, performance, aesthetics. Right? Can I afford it? Does it work? Will it perform the way I want? And to that we need to add ecological, because we need to really understand what these things are made of and where they're going to end up.
Great, Lauren.
Ditto.
That's wonderful. Well, in our closing 2 minutes, if you were going to ask a company to do something, what would you ask them to do? And Lauren, you go first here.
Oh boy, specifically with
with regards to material health, what is your ask?
Okay, well, here I'm gonna live a little dangerously right here. I'm going to say that you need information on the ingredients. Suppliers need to provide information on the ingredients that they're selling and make that information publicly available so people can make informed choices. And and it's not just, Jay and I may be, environmental people, but we're not. This is a paper published by BASF. I believe it's the biggest chemical company in the world. Basically, it's not enough to just use free of the RSLs. you need to have chemical hazard assessments to determine whether potential ingredients have sufficient data and low enough hazard to support their long-term use. Take that from Pat Harmon and Rainier Otter of BASF. We're not this isn't a crazy idea. It's understood by those who make chemicals that this is the future. This is the way we have to go. So this is dangerous because the other times I've presented this slide, the system always tends to crash, but I think we're okay here. So it's important, I think, to say that.
Wonderful. What's your ask, Jay?
To hire me. No, I'm kidding.
Yeah. Right.
No, to Lauren's point, and I think we've said it here, that RSLs are not enough, but I would go beyond. I think they're actually dangerous to a false sense of security. So I would say, let's just get rid of our RSLs and say, look, we're going to focus more on transparency and understanding exactly what's in our stuff, not worrying so much about what's not in our stuff.
Wonderful. Well, thank you both so much. I knew this time would fly. I am sure I can say that you're both open to anyone who would like to contact either one of your companies to learn more about this. Also, if anyone would fill out the questionnaire, the Survey Monkey on this session, that would be appreciated. And I get the final word as the moderator. So you don't necessarily understand SAFE until you try to make it circular, and RSLs are not. Those are our two big takeaways. Thank you all for joining us, and thank you, Lauren and Jay.
Thank you so much,
always
Heine.
a pleasure. Bye.
Thank you. Bye-bye.